Standard disclaimer to everyone. We are now recording. If you do not want to be recorded in video on accident or voice on accident, I ask that you turn your video and audio off until we tell you that the recording has stopped. And then once it is stopped, then you can feel free to re-engage.
And I have one more announcement before I turn it over to Scott, which is that the committee for this morning's presentation is myself and Professor Tobias Hollerer. Professor Hollerer is on a time crunch, unfortunately. We've timed Scott's presentation that comes in right about 45 minutes. What we'd like to do is ask you, we definitely want lots of questions and engagement from the audience, but we'd like you to hold your question. You can put questions in chat at any time, but we'd like you to hold your verbal questions until after Professor Hollerer has had a chance to ask his questions. At the end of Scott's presentation, we'll go to Professor Hollerer for questions first, because he does have to leave. And then once he has finished his questioning, we'll open it up to questions from everyone else. So with that, I think I would like to turn it over to Scott Chow.
Thank you. All right. Good morning, everyone. I'm Scott Chow. I'm defending my master's project today, and it is on teaching testing with modern technology stacks in undergraduate software engineering courses. I know, real short. So let's start with a little bit of a scenario. Consider the following. You're asked to teach a project course, and one of the many topics you're supposed to teach is testing. So you design some labs around testing, but they're all relatively simple, and more importantly, they're self-contained pieces of code. So when it comes time for students to build out and, more importantly, test their own projects, when they turn around and ask you how to test their project, you might be caught in a little bit of a difficult spot because, well, there's a variety of reasons. You might not be familiar with the particular language they're using. You might not be familiar with the particular technologies or libraries that they're using. It might even be that you're not particularly informed with what or how to test at least their particular type of application, right? And as a result, it's common, if a little bit regrettable, that we give students credit for testing if they even at least make an effort to test. They write one or two tests or make a video manually demonstrating the fact that their code works. So we have, and it's not like we don't have testing in, sorry, I'm gonna go ahead and hide this floating meeting controls. It's not like we don't have testing in the undergraduate curriculum, but it tends to be relegated to the lower division and entry level courses. And when you do find it in upper division, the systems under test do not resemble the most common systems you will find in industry. And even when you do manage to find the courses that do have both testing of, say, web applications and are in curriculum, it tends to be graduate courses or highly specialized undergraduate programs. So that brings us to the goals of my project. The first goal is to modify the curriculum of, in this case, Computer Science 156, to introduce testing of more complex and modern applications. Our second goal is to measure students' perception of testing, both before they take the course and after they take the course. And the research questions below reflect these goals. Research question 1 is mainly for goal 1. Can we get students to test their code? Research question 2 is asking, how did students see testing before they took this course? And research question 3 is asking, how did they see it after they took this course? And more importantly, did anything change? But first, I need to set some context. And more specifically, I need to give you an overview of what this course looked like before this project. So Computer Science 156, I'm going to refer to as CS 156, is a legacy code project course, and its primary goal is to provide an authentic understanding of industry software development. The course is split broadly into 2 phases. The first phase is more of a traditional class. Students all receive the same assignments, they all complete the same programming labs. And the goal here is to teach the basics they'll need in order to meaningfully contribute to these legacy code projects. So we teach them Java, the basics of testing and test coverage in Java. We teach them Spring Boot, which is the Java framework we use to build these legacy code applications. And we teach them some of the basics of web app development, like what's a database, what is an API, and why do I care what the difference between the front end and the back end is. Next, and in the name, is the Legacy Code Project, right? And this is where groups of 4 to 6 students will work together as a team on one of 3 projects. And they'll be working to complete a group of features known as user stories, and the group of them is known as an epic. And we see here there are 3 particular projects that are fixed from quarter to quarter. And the idea is that one quarter will make changes and the next quarter will inherit those changes. So we have Courses Search, which allows students to search for courses at UCSB. We have the CS Tutor program, which helps the tutor program at UCSB manage office hours and TALA assignments. And we have Mapache Search, which instruments, searches, and analyzes Slack workspace archives. So now that I've shown you what the course used to look like, I now want to introduce or review some of the basics of software testing as they appear in this project. And in order to do that, let's begin with the why. Now, the why is, a lot of us may know it, right? But we're going to clearly define some of the reasons and the most important reasons to this project. So if you have good tests, one benefit is that you have greater confidence that your code actually functions. You have proof, essentially, that your code works. You don't have to say, oh, I tested it one day on my local machine. You have proof. Good tests also give you better confidence when changing code. You don't need to be intimately aware with every piece of the code base if when you break something by adding a field, taking away a field, it fails tests somewhere else in the project that informs you what broke. And finally, and probably most near and dear to academics and people who have to teach and grade, is that automated testing means automated grading. And if you've ever had to grade 140 different web applications by hand, like I have, this is probably one of the bigger things, at least for teaching a course. So now that I've given some motivation for why we care about testing, I'm going to go ahead and define some terms that we use. So a unit test, right? These are some of these are different types of tests, others are techniques. Unit test, the goal of it is a test that verifies a single behavior of a single component of code. And so think a single function of code. And the goal here is to try to isolate the component under test as much as possible, with the idea being that unit tests for component A should only break if I change component A and not if I change component B. On the other hand, we have integration tests. And the goal here is to verify a single behavior about multiple components. And the goal here is to catch communication and API errors between the components. And these would not be caught by unit tests because, well, the unit tests are not supposed to be integrated. And finally, we have the concept of mocking. So mocking at a high level says, I'm going to replace a dependency of a piece of code with a mock. And what a mock is something that imitates the interface of the thing it's mocking. But it allows you to swap out the behavior of this interface on the fly, which is what allows you to essentially isolate different components of code from other pieces. So I've talked a little bit about what makes it, like, needing good tests. So what makes a good test? And broadly speaking, there are 3 portions. There is an arrange, an act, and an assert. Arrange means you set up the test's assumptions. This could be anything from the environment to the database to the dependencies, even so far as what operating system you're using. We have the act portion, which the goal is to exercise the behavior. This means you just trigger the behavior that you want to call. So this could be calling a function. This could even be clicking a button. And finally, we have assert. Assert means that you actually verified something about the code, that it behaved the way that you expected it to. And this could be via a side effect or an output. So consider let's look at it in an example. We have here a form that's being filled out and being submitted. And the goal here, and say, for example, we wanted to verify something about this. We wanted to verify this behavior. Let's say, for example, when I successfully submit this form, I want to verify that I got redirected to a new page, right? I want to verify I got redirected to this new page. So let me go ahead and show you an example of what this looks like in the code base. So we have here so this code that you're seeing here is JavaScript. It is written in the React framework. And what I want to draw everyone's attention to is that the output or the look of the page is handled here in the return statement. We see, for example, the title of the form, add new tutor assignment, and then we see a tutor assignment form below it. What I want to really zero in on is this create tutor assignment variable that's being passed to the form. And more specifically, I want to look at its creation, because this create tutor assignment is passing the behavior. How should you create this tutor assignment to the form? And that behavior is being handled up here. So create tutor assignment is built by build create tutor assignment. And there's a lot of things in motion here, but what I want to really point out here is that there's two things that are required to build this function. You need an on success behavior and you need an on error behavior. And more specifically, in the on success behavior, we notice a history.push. This is what causes you to redirect to a new page, right? So we've now identified something concrete we can verify to say that we have proof that we went to a new page if we called history.push with tutor assignments. So let's take a look at the testing code required to do that. We see here the test, and I've gone ahead and added some comments to split out the three different portions. We have the arrange portion up top that goes ahead and mocks out the history.push function for us so that we can listen in on it. I've also gone ahead and rendered, or the test has gone ahead and rendered new tutor assignment so that it appears in the test. And we've gone and identified the submit button. The act portion is very short. All we do is we hit the submit button. And finally, in the assert, we check that push spy was called once, and we expect push spy to have been called with the correct arguments. That is how we were able to assert or verify that we went to a new page. So now with that example out of the way, we can get back to the presentation, but hopefully that helps square a little bit. These are the types of tests we were writing during this course. And worth noting, a student wrote both the implementation that you saw and the test that you just saw. So another topic that I would like to go over quickly, and let me hide the floating meeting controls, is code coverage. Basically, the question we had was, how do you objectively measure the quality of a test suite? And one of the many answers is code coverage. Now, code coverage's goal is relatively simple. The idea is that, oh, sorry. I'm not sure what happened there. Let's put that back. The goal of code coverage is fairly simple. If you don't run code, you can't catch bugs in it. Right? So there, like most things in computer science, there are both or I should explain, code coverage works by counting the number of times a line is executed during the execution of the test suite. So what these number twos we see here means that this line of code was called twice over the course of many tests, right? So like most things in computer science, there's a trade-off to using code coverage. So some of the pros is that it's relatively simple to explain and understand. It's also very easy to display because it maps so well to the code. And furthermore, there's a lot of mature and well-maintained tooling around code coverage. Many different testing libraries support tracking code coverage. But some of the cons are that the closer you get to, so diminishing returns means the closer you get to 100% code coverage, the less you might be getting out of having said code coverage. Also worth noting is that code coverage does not mean you actually checked anything about the code. In the extreme, you could exercise every bit of code, but if you never actually have an assertion anywhere in your tests, you haven't actually checked any behavior, right? So it's not a perfect one-to-one. And one moment.
Can I jump in with a question real quick? When
Absolutely.
you're talking about code coverage, are you referring mostly to statement coverage, or do you also consider branch coverage?
This is statement and branch coverage.
Both, okay.
For both JavaScript and Java.
Okay.
In the extreme, developing around code coverage can sometimes hurt implementation, where it might make what's normally something straightforward to implement very difficult because you are engineering with the idea that this needs to be testable. There's trade-offs always. So there are some alternative quality metrics out there. One of them is mutation testing. And this is mutation testing. The core idea is take the implementation code and change something about it, make a mutant out of it. And if you make a mutant out of it, the test suite should catch that mutant. It should identify and fail that mutant. So that's how mutation testing works. And worth noting is that we added this was added to one of the class assignments in the new version of this course. But this was done independently of this project, and adding mutation testing to the legacy code projects is going to be left as future work. Another idea is another related metric is this idea of checked coverage. And checked coverage refers to what if we tied coverage not just to what code you executed, but say for every assertion, we looked backwards and we say, what code was run to hit this assertion, and only awarded coverage for those lines of code, right? That's the idea of checked coverage. And we, in this case, were not able to implement it and we couldn't find the resources and tooling required to instrument our projects and assignments with. And finally, we come to this idea of all pairs comparison. And the idea here is that you take student submissions, which is both an implementation and a test. You take one test, a student test, and you run it against every other student submission and see how many of those student submissions it can catch as having some flaw in it. And while this might work in the traditional portion of the course, due to the different natures of the legacy code projects in the second half, you can't really do an all pairs comparison between the different legacy code projects, which makes it difficult to apply in that context. So now that we've gone over some software testing, I'm now going to introduce the tech stack used in both the legacy code projects and some of the assignments. So our new tech stack, well, first, let me clarify something. Computer Science 156 was already in the process of transitioning to a new tech stack. Pictured here, React, Spring Boot, and Heroku, this was going to be the new tech stack that we pivoted to in the absence of this project, right? So what I added is as follows. I've added all of the testing frameworks in this case, and the test coverage frameworks. So we see here on the left, again, we have our frameworks, but for the front end, back end. In the middle, we have our testing frameworks. And at the bottom, we see GitHub Actions, I'd like to point out, because this is where we run all of our tests. And this is what we use as our continuous integration or continuous improvement platform known as CI. And on the right here, we have our code coverage tooling. So Jest makes an appearance again, Jacoco for JavaScript and Java respectively. And we have code coverage at the bottom to serve as our online repository for all of the coverage reports that get published by GitHub Actions. And just to reiterate, this part is my project's contribution to this course, is integrating all of this into the legacy code projects. So, also worth talking about is the way we organized code in these projects. And at the beginning, we split it out into a backend and a front end folders. Worth noting, the front end is actually a folder within the root of the backend. So it is still a single repo, but the front end is considered a subfolder of the backend. Now, within both the backend and the front end, we split out the code into main, which is implementation, and test, which is for testing. We did this primarily because Java had this strict requirement to do this in the back end. And in order to have auto grading be made significantly easier, we decided to take a similar split in the front end. But there are some additional benefits to having this split. One is for every implementation file in the main directory, its corresponding test file can be found in the test directory. This means that if you're ever looking at a piece of code and you're wondering where the tests are that are responsible for testing this, you can easily find it by finding its twin file in the test directory. So there's a direct one-to-one correspondence. But there's an additional benefit, which came from the fact that we bucketed code files based on their general behavior and their general patterns that they followed. So for example, in the front end, we have controllers and entities. While in the back end, we have controllers and entities, and the front end, we have components and pages. The benefit here of doing this is that code that behaves in a similar manner, that serves similar functions, tends to be designed in a similar way, right? And if code that you're implementing is designed in a similar way, your tests tend to be designed in a similar way to exercise it. So the benefit here is that if you're ever stuck, if a student or even a staff member is stuck on how to write tests for one component of the application, and there's no existing test file for it, they can look at other test files within the directory. So I can look at other controller tests to see how should I exercise this controller and get a better understanding of how to go about doing that. Obviously, it won't be perfect, but it can give you a better understanding of what should this even vaguely look like. And with the tech stack overview done, I can now explain to you what the course looked like after our modifications. So in order to better incorporate testing into CS156, we focused in 3 points. We created instructional materials that integrated testing. We built an example application that served as a proof of concept, and we re-implemented all of the legacy code projects with the new tech stack. So in terms of the instructional materials, we contributed a React calculator lab and the to-do web app as 2 different labs. The first one had the goal of introducing students to both JavaScript and React, as well as how to test in that context. The second was the to-do web app was focused on introducing students to how do you configure and deploy something more complex than just a hello world application. Worth noting is that while the menu and menu item refers to a lab that refers to the lab that introduced mutation testing. I introduced mutation testing as well as testing and code coverage in Java. This was done, it's not bolded because it was done independently of this project, but may have had an effect on the outcomes. So we've listed it here. I want to point out that the to-do web app was really a key contribution of this whole project. It served as the proof of concept for the tech stack pictured in the bottom right-hand corner. It really demonstrated that this is what an application looks like that has all of the different pieces. And the reason that's important is because A, we could onboard course staff to the new tech stack because we could ask them to work on extending the To-Do app, for example, right? And understanding the To-Do web app. It also was important because it served as a prototype application from which we could cut down and pare out functionality to make kind of a prototype to build new assignments off of, and in this case, re-implement all of the MVPs for the legacy code projects from, which is a lot faster than starting from complete scratch. And finally, we re-implemented all of the MVP legacy code projects. The main reason we did this instead of trying to pivot the legacy code projects to the new tech stack is we believe that it would have incurred a significant amount of tech debt. And we didn't think that that experience was particularly valuable to the students in coming in that shape and form. We thought it would be more engaging. It would have been very realistic, but it would be far more engaging if they could work without the burden of, say, 2 years of tech debt as a result. So now with the modifications out of the way, we can evaluate how we did in the course. And to begin, we're going to answer the first research question, which is, did we get students to test their code? And what I have pictured here is the code coverage over time for these 3 different repos. All 3 we handed off to the students at 100% code coverage. 2 of them maintained 100% code coverage, while the courses search application only missed 100% code coverage by 7 lines out of 1,474. In total, I've shown here the number of new tests that were added. It totals up to 707 new tests written by students.
So can you mention what the x-axis denotes?
Yeah, so the x-axis denotes time, and more specifically, the dots demonstrate when different pull requests were merged. Essentially, different units of student code was added to the code base. So worth noting is we noticed some dips here in code coverage. These big dips here were actually as a result of instructors adding untested code. So in particular, one example was we asked one of the teams for the Mapache search app to work on a Slack bot. However, we hadn't provided them even a shell of a Slack bot. So this first big dip here represents when Conrad came in and added a kind of hello world Slack bot app. But due to time constraints and because we wanted to get the code to students quickly, didn't go back to test it until later. And it's worth noting that there is a small portion of these tests that were instructor written as a result. However, I'll explain it later in the threats to validity. We don't believe this to be a significant number.
One more question.
Yeah.
Second graph, the 2 different shades of pink indicate that there is a section missing from the blue area.
So there's 2 different metrics being tracked here, line coverage and complexity coverage. And in this case, it was referring to the difference that you denoted earlier, essentially the difference between statement coverage and branch coverage. So that's the difference being displayed there. In fact, what's being shown here is that there were less branches covered, right? That if you were to count the lines, you would have 80% code coverage. If you were to also count the branches, you would have under 80% code coverage.
All right, what about the square to the right of it? Why is there a missing blue part?
I believe that this might be an artifact of when I took the screenshot. I accidentally moved my cursor over those 2 portions, and it was then highlighting those 2 portions. I don't believe this actually has any actual meaning otherwise.
Okay. Yeah, when you show graphs, please go over what the different visuals mean.
Absolutely. So we're now going to compare the statistics in terms of testing from the winter 20 version of this course, the former version of this course, to the fall 20 version of this course. So pre-modification is winter 20, post-modification is fall 20. And what we see is, well, we vastly increased the amount of testing being done in these legacy code projects. I mean, the most absurd increase is from 2 to 368. In terms of code coverage, we also saw similarly large gains from anywhere from 30 to 99% from up all the way to 1 to 100% increase.
Can I ask another question?
Yes.
So where is this apples to apples? I mean, or was in post modification, was there a requirement for a grade that actually included more testing, or,
Yes.
or was it the same situation for both classes?
So in this case, and that's absolutely worth pointing out, is that we strictly enforced coverage in the second course, whereas in the first course, there was no such strict enforcement.
Was there
So that's
benefit to people's grades in the first course? To do for
I don't
doing
believe
testing?
I don't believe we have that information in terms of the grades and the outcomes. We do not have the information in terms of the differences between the first course and the second course.
Can you clarify
What's
the
your-
a little bit, Tobias? What are when you, yeah, what are you asking about the difference between the two courses?
If there was a requirement in one of the courses for testing that there wasn't in the other.
Yeah,
For
Yeah.
I should clarify then, there
Yeah.
was requirement for testing in both courses. However, in the second course, the post modification, the requirement was made much more stringent because now we actually had code coverage introduced into the legacy code projects. And the idea was that your code would not be merged unless if you dropped code coverage.
Right.
Given that it began at 100%, that meant that students need to maintain 100% in order to get their code merged.
Right.
Yeah,
Yeah.
With the
also-
obvious exception of
I also want to point out that you shouldn't misunderstand my question as an indication that I believe that the act of grading or imposing grade requirements will actually lead to like better performance or insights. So I want to ask you actually on your impression, but I'll wait for that question for after your presentation.
All right, sounds good. So worth pointing out here is that if you average the number of tests over the number of students, it results in an average of 10.7 tests per student. And as compared to winter 20, where we had an average of 0.6 tests per student. Now we arrive at research question 2, which gets at how did students perceive testing before the course? And what we see is a little bit of a story, and I'll first want to go over the graph. Thank you, Oliver, for pointing that out, is that what we're using here is a Likert scale. So 2 in this case refers to, there's a statement written at the top, and students are asked whether or not they agree or disagree with this statement. And the scale goes from strongly disagree, which is a -2, all the way to strongly agree, which is a 2. 0 stands for neither agree nor disagree. So this first statement here is, I feel that writing automated tests helps me catch more bugs in my code. And a majority of students agree that these tests are helpful for catching bugs in the code. So students are hearing us when we say it. But if we take a look at the second graph in the second statement, I feel uncomfortable figuring out how to set up testing for projects and assignments. We see that a majority of students also agree to this statement as well, when we begin to see what may look like a little bit of a gap. Furthermore, if you ask when asking students whether or not they wrote their own automated test suites, a majority disagreed. And finally, if we asked students whether or not they failed to write tests because they weren't sure how to set up testing, a majority of them agreed with that statement. So obviously, these are self-reported results from a survey. But what we begin to see is the shape of something that looks like a gap between students maybe wanting to test, but not necessarily having the tools to test if you don't provide testing for them in their assignments. This is further backed up by the fact that students strongly or tended to disagree with the statement, I didn't test my submissions. and while agreeing with the statement that they used pre-written tests and feedback from Gradescope. Also worth noting here, and this is more so we can compare to this later, is we asked students, if you spend 10 hours on a programming assignment, how many of those hours would you spend on testing? And we asked a similar question for out of 100 hours. And what we saw were the answers were fairly similar, even as it scaled. You had a little over 2 hours for out of 2 out of 10 hours, and you had around 18 hours out of 100.
Did you ask these questions one directly after the other?
Yes, all of the questions pictured here were asked in the same survey, which may have introduced some bias. That's absolutely true. Third, for our third research question, we asked, how did students' understanding, essentially, how did students' perceptions of testing change as a result of taking this course? Well, whether or not it was a result of taking the course, we'll see, but how did they change after taking this course? So what we got here was potentially something that looks like a conflicting result, right? And I want to note these results are fairly modest. And I want to, again, go over the graph. What we're seeing here is now the delta between student responses. So a -3 means a student became 3 degrees more negative to this same statement than they did from the beginning. And we were able to do this because students were assigned response IDs from the pre-survey, which they entered into the post-survey. So -3 means I went from somewhat disagree or somewhat agree to strongly disagree, for example. So we noticed modest movement, but in the negative direction, that students feel uncomfortable figuring out testing assignment, how to set up testing for projects and assignments. So if you factor in the double negative, it means students became more comfortable with how to set up testing. On the other hand, we had movement in the other direction, where it looks like students became more uncomfortable writing tests because they weren't sure how to set up tests and testing. And a potential explanation for this is that in the second, in responding to the second statement, students might have been reflecting on their previous behaviors instead of reflecting on their current behaviors, and highlights an issue with wording that we talk about in threats to validity. And for completeness, we asked a similar, we re-asked the question about how much time students would spend testing for 10 and 100-hour programming assignments. And we noticed, again, fairly modest gains in terms of the amount of time students would estimate they would spend on testing. And if you were to look at these results alone, the qualitative gain of this course is modest if it exists. But we took the liberty of asking an additional question on the post survey, which is, what impact has this course had on how you view testing? And the responses we got were, while these are cherry-picked responses, they at least informally, they seem to be representative of the whole, and more rigorous content analysis will come later. So we have one student who said that they feel more comfortable writing tests, another highlighting that they appreciate the value of having solid tests for code. One saying that it made them view testing as a larger aspect of the software development lifecycle. One even saying I should be testing my programs more. And another highlighting that they didn't know about the resources available for testing, such as code coverage and mutation testing. And here we see something more of a qualitative impact on how they view testing. Worth noting is that, again, these are self-reported results as delivered by the instructors of the course. So this naturally could introduce bias. And speaking of biases, we have threats to validity. So in terms of internal threats to validity, was it the course or was it something else? As Professor Haller highlighted before, test coverage in this new version of the course was a strictly enforced parameter, as opposed to previous courses where test coverage wasn't even tracked and test counts weren't even tracked. Which means that when examining the results, you can't say it made students test more. What we can show is that we can make students can test under these conditions, I think is a little bit of a safer statement. Some of the added tests were from instructional staff, but we do not believe this to be a large percentage of the test. We would be surprised if it was over 100 or if it was even over 50 tests. Furthermore, the surveys were delivered by instructional staff, which again can introduce bias, as students may believe that their responses may have some direct or indirect impact. We tried to limit this by telling students that their responses were completely anonymous, and they were completely anonymous. The only thing we could track was the RFIDs, but there's no assignment from student to RFID. And finally, furthermore, the survey results were obviously self-reported, and self-reported results are not necessarily completely objective measures of what you ask. And finally, we did introduce some survey fatigue, partly on accident, partly because partly on accident. We were asked students to fill out, I believe it was 2 to 3 surveys over the course of a day or two. And that might have introduced some bias into the code. I'm not necessarily sure bias in which direction, but it certainly can cause students to move more quickly and more expediently through the survey and maybe not give it the attention that it deserves. In terms of external threats to validity, which is, can we generalize this? In terms of what technologies are available, while we tried to choose metrics and technologies that are generally available, such as just your average testing framework and code coverage, the availability of these different tools varies from tech stack to tech stack. And as well as in terms of, for example, a new language might not have a testing library out yet, it might not have a code coverage tool out yet. Furthermore, if you're trying to test different types of applications, there might be difficulties achieving full test coverage depending on how you interact with a third-party library or a third-party API. And finally, in terms of constructive threats to validity, did our metrics actually measure what we looked out for? Worth reminding again and again is that coverage does not necessarily mean quality. You can say, for example, that the absence of coverage, where if you don't have coverage, you're definitely not doing a good job. We can at least show we're not failing in terms of coverage. But it says nothing about necessarily the quality of the tests that produce that coverage. And furthermore, as I've highlighted previously, the survey questions in retrospect suffer from wording issues, to say the least. Finally, excuse me while I take a drink of water. We have a fair chunk of related work. Beginning with Brooks and the Mythical Man month, we look at the question of how much of a project is actually spent on testing. While the Mythical Man month says 50% and a more recent paper from Beller says 25%, if it's anywhere from 50 to 25%, the point remains the same. Testing is a significant part of the development lifecycle. It's not an exception, it's the rule. So there were calls for more testing in CS and software engineering education long before this, but worth noting, I'm going to limit myself, aside from the Mythical Man month, to the past 20 years of literature. So Jones and Christensen in the early 2000s put out a paper saying that testing, the computer science curriculum is already fairly saturated. And furthermore, you shouldn't make a new course out of testing for saturation reasons, but also because testing would be better integrated into every topic instead of being a separate topic all of its own. And Desai et al. In 2008 made good on this by showing that in introductory courses, you can indeed introduce testing without inflating the course material and the number of topics being covered. Also worth examining is the history of is some of testing that occurred with Java GUI applications. So Sun and Jones in 2004 and Thornton et al. In 2008 demonstrated that students can indeed be taught to write tests for Java GUI applications, and that students tended to benefit from perhaps the visual nature of these tests. In this case, the Java frameworks that they were testing with have now since morphed and changed to be much more complex and fairly different, I would say, from what they were. In terms of test-driven development, which makes its appearance here, is we have Kent Beck defining TDD and introducing TDD as in the early 2000s. And we have work from Tinkham and Kaner and Kalanis and Isamatoten that demonstrate essentially a balance that needs to be struck with introducing students to TDD. If you make the tasks too easy, the former paper demonstrates that students tend not to adopt TDD because they don't see the value in it. And similarly, if you make the task too complex, the latter demonstrate that students are perhaps struggling with the task itself so much that they don't have any room left to think about testing it. Worth noting is that we have evidence that testing indeed improves correctness from Avalar in 2019. While certainly not the only paper, this paper serves as a good aggregation of other papers that support this claim. Also worth highlighting is that there are other papers, other experience reports of doing web app testing in courses, but there are caveats. For example, Hu et al. In 2019 details this, but the unfortunate part is that it's a grad course where there are, in large cases, different expectations both on student motivation and prior knowledge. We also have Krutz et al. In 2014 detail a program in undergraduate curriculum for web app testing courses. However, worth noting is that this paper is an experience report from RIT, where not only are the class sizes smaller, but in this case, the program they were referring to at RIT was years, if not decades in the making. And it adopted a FOSS approach, which stands for free open source software. And the issue with FOSS is that while it provides really awesome experiences, it doesn't scale well with the number of students. It certainly doesn't scale to 60, and it certainly doesn't scale to 100 students at a time. Furthermore, we have automated feedback and grading as a section here. We have Edwards in 2003, who put out WebCat, which is incorporated testing and auto grading. Baffardi made, sorry, I need to scroll down here. Baffardi demonstrated in 2012 that students adopting TDD were correlated with students adoption of TDD was positively correlated with positive outcomes in terms of grades. Perez Quinones in 2007 demonstrated that WebCat feedback could be altered. Its feedback mechanism could be altered to be made more useful for students. This was done by feeding students hints, but not just for free. You fed students hints in return for having them increase testing coverage on their submissions. Furthermore, we have Hu and Geringer in 2019 demonstrating that if students received feedback on their code, their programming assignments in the form of PR comments, pull request comments, students were generally receptive to this feedback. And finally, we have Kazaruni in 2019 putting out a paper demonstrating that coverage was that you needed to balance the testing effort. You couldn't just, if you did all your testing effort at the end, that tended to be negatively correlated with actual coverage. And furthermore, demonstrated that the coverage was more so positively correlated with the amount of test effort per work section as opposed to whether or not you were following TDD in a test first manner. Finally, we get here to future work. One of the big holes in our testing framework at the moment is a lack of end-to-end testing. And this is where we would introduce technologies such as Cypress and Test Cafe. And this was a particularly big issue because a lot of times some of the issues we suffered from were that we had a lot of unit testing. The frameworks we've introduced are very good at writing unit tests and small integration tests but they tended to suffer when you actually were looking for full end-to-end functionality. It's not as easy. It's much easier to use these types of technologies like Cypress and Test Cafe to instead automate a browser to go ahead and test the full end-to-end functionality, as opposed to trying to test end-to-end functionality within something like Jest and React testing library.
Can you give an example of end-to-end testing?
So an end-to-end testing would be the following. Instead of rendering the page like I showed in the example, you would instead say, Cypress, visit the browser at localhost 3000. Then can you please identify the element that says tutor assignments on it and click on it? So, and then can you please go ahead and navigate to the new button? Can you then navigate and fill out this form, and then can you hit submit? And so besides the browser automation being done at the browser level, as opposed to the necessarily within a framework like Jest and React testing library, the other key difference is that instead of mocking out the backend, where your backend is where your front end tests are typically isolated from your backend, and vice versa, you actually have both the front end and the backend running at the same time. So, for example, if the front end is calling an API that doesn't exist, your unit test may pass, but your end-to-end test will fail because that API actually doesn't exist in the backend yet.
In your estimation or in your experience with these projects, does end-to-end testing always involve simulation of the human user? That's what you just described, right?
Yeah. So yeah. Like the goal, yes. So the goal is to mirror the actual user, and in a lot of these cases, for example, Cypress actually has functionality, for example, to better mirror user, for example, typing by saying, oh, don't just instantly paste the contents that you're typing, actually hit the keys with 0.1 second delay. So in that sense, yes, the goal of end-to-end testing is to actually mock what a user does through the browser and test, can they successfully do it when we expect them to be able to successfully do it. Another idea for future...
To follow up on Tobias's question, how would you characterize the words white box and black box in terms of the different kinds of testing you've talked about?
Yes. So the testing that we have introduced, in large part, with maybe small exceptions here and there, is white box testing. You are testing with the clear understanding that you know how it's implemented. The test I showed as an example is an example of white box testing, where we didn't check that the way we checked you redirected to a new page was we checked that you called this very specific function that we know redirects you to a new page. If you, however, change the mechanism you use to do that, the test will break, right? So whereas end-to-end testing is much more, you could argue it's much more robust in this manner. It doesn't know anything about what's actually happening in the React app or in the backend. All it sees is, like the user, the browser. And all it can interact with is the browser. So end-to-end testing
necessarily know that it's React, right? It could be implemented.
It doesn't know. Yeah, it can be anything.
Entire implementation, and as long as the UI stays the same, the test would still pass.
Precisely. That is yes. Because at the end of the day, Cypress is actually more so a browser automation tool more so than a testing library is the way I like to explain it to people. Its first goal is to be a browser automation tool, and it can also test things about the browser.
Scott, looking at the clock, I have 2 minutes, and I do have a few questions. Can I ask them now?
Go ahead.
Yes.
Yeah. Okay. So you're pretty much through, right? So
Yes.
Great talk, by the way. Thanks for the presentation. So first one on the survey. So I noticed that you are really interested in how well do students test before and after, right? That's really what we are interested in. But what you asked them was how much time are they willing to spend before and after? So you're conflating two things there, right?
Yes.
Like how much time they're willing to spend and then how time efficient they are. It's quite possible that your new teaching methods actually made them much more efficient. So at the same time that they spend results in much better testing. So that's one thing. And I was wondering, I don't think I have time to hear in detail from you, but I was wondering if you had any indicators in your survey that actually lets you draw a conclusion about how efficient they could do testing. So that's number one. Number two, I think you still can, even if you said there were modest gains in the number they were willing to spend there, with more efficiency, it may be even more. I would urge you to do a statistical analysis if that was significant. You have enough users to do that in your survey, about 50. It is still possible that you, even though they're close together, that you will actually get a statistical significance. If you're not sure how to do that, I can certainly help you with that. But I think that would be really worthwhile to do. The other question, real quick, that I had before that I said I would ask you later was on the quantitative coverage, right? So in the two courses. And so there I asked, well, but you introduced new requirements. So here I would like to ask you, what would have happened, do you think, if you made it a graded course requirement, but didn't introduce your new technology stack and methodology, right? Can you just think about what you think would have happened?
Yeah, well, so I actually don't have to think what would happen. I can tell you from experience what did happen, because we went in with the ideal that we wanted students to test. We wanted students, and actually, so I should walk that back, that statement. We wanted students to test. And to some degree, if we had made it a hard requirement that students actually achieve code coverage on their tests, we, the core staff, would not have had the tools to understand or help students achieve it. We wouldn't know how to do it ourselves, which then would make it borderline impossible for the students to do it. So it's difficult to compare one-to-one, because part of it is, in order to really compare, the course would have had to fall apart at the wheels, essentially.
Yes.
In that respect.
Got it. And with this, I have to drop off. Thank you so much for your presentation. I'll be in touch with you and Professor Conrad after this. Thank you.
Thank you. Thank you, Tobias.
Thank you.
So, Scott, what I want to do is I want to make one point in response to the line of questioning that Tobias just was engaged in. And then I want to let you just kind of finish off your last couple slides,
Sure.
and then we'll throw it open to questions from the audience. And actually, maybe before we even do that, I can ask a few questions that were on the chat. But first, the point I want to make, I made this point earlier in the chat, but I'll make it here. It fits well. Is I think in large, let's see if I can find it in the chat. In large ways, the most significant contribution of Scott's project is the fact that he put together an entire full stack web app using the stack we were using to teach this course, and instrumented the entire thing for testing. So every aspect of the front end, every aspect of the back end, we had an example of how to test that. And Scott then used that to train me, the instructor, the fellow TAs and fellow LAs. For anyone who doesn't know, that's the UCSB word for undergrad TAs. Train the entire course staff on how to do the testing. That enabled us to then teach the students how to do the testing. And that's been the main barrier. I've been wanting to do testing in this course for several instances, but I just didn't know how, and I didn't have the cycles to teach myself how. That's, I think, the main contribution that Scott has made here, is to figure it out on his own and then teach the rest of us. So with that, Scott, go ahead and finish your slides, and then I'll pose to you a few questions from the chat, and then we'll open it up for questions from the audience. So go ahead.
All right. Then we'll go through this fairly quickly. One of the things we'd like to introduce is React Storybook. This is just as an additional testing measure, a visual testing measure for the front-end components. Mutation testing would be great to integrate into the legacy code projects as well, for at least the Java portion and also the front end, the JavaScript portion, because this would actually help us give some bite behind the code coverage. Not only are you covering code, but you can actually check for changes in that code, which is essentially what mutation testing is attempting to demonstrate. Obviously, different survey questions that were more geared towards specific like quality of testing and student engagement with testing would be great to follow up. I put focus groups here. We actually did run a focus group with the students of Computer Science 156, this iteration of it. But we did not have time. I did that focus group on Tuesday night, and I haven't had even time to go back and transcribe it, much less actually look at the results from it. And we're interested in, and will likely be submitting a paper to IDICE 2021 based off of this work. Broadly speaking, the contributions really quickly, we changed CS 156 to have significantly more testing. We enabled students to test web applications or build on web applications while actually maintaining test coverage. We took a survey of students before and after the course, and an informal analysis of students' comments suggests that we improved awareness and attitudes towards testing. Really quickly, some acknowledgements. Philip Conrad and Tobias Hollerer for being my faculty advisors. In addition, Professor Conrad for giving me access to CS 156 to change. In addition, my fellow teaching assistants, Mara Downing, Zach Sisko, Pingyuan Wang. The learning assistants for this course who go above and beyond every time to learn the tech stack and help students in every way that they can. Andrew Liu, Dara Burke, Gabriel Sewell, Tanae Kamarlu, Brian Terse, Jacqueline Mai, and Cole Bergman. And also some particular undergraduate research that helped bootstrap some of the testing in Spring Boot, which are Tanae Kamarlu, Brian Terse, Jacqueline Mai, and Cole Bergman. And finally, none of this is possible without the students taking the course. So to the students that are here and that are not here from this past version of CS 156, I thank you. Questions?
All right, and I said I was going to go over the questions in the chat, but I think instead of that, I'm going to invite the people who asked questions in the chat to just.
I take like a 1 minute break to go to the bathroom.
Oh, please, absolutely. So we'll take a 1 minute break for Scott to go use the restroom. And while that is happening, I will just want to recognize we have some faculty from other institutions here. So I want to give a shout out to them. Thank you for being here. There's also some alumni of CS 56 and 156 have joined us from industry, as well as some past CCS alums and some students from the course. So I'm looking forward to hearing questions from all of you. And also a meme credit to Andrew Liu. For the meme there on the slide. So Scott will be right back. In the meantime, if you have a question, you can raise your hand in the participant window on Zoom. I think there's a place where you can click raise hand. Great. I see Corey has his hand up. So Corey will get the first question when Scott returns. And then Tony Wong and Chris Hundhausen. Excellent. So we've got, and Jackie Mai, we've got some questions lined up. Excellent. All right, Scott, welcome back. The first question comes from Professor Corey Bart of the University of Delaware.
Hi, Scott. Thank you for this presentation. It was very interesting to hear about your work. I think my biggest question is, I wanted to hear more about the nature of the course changes that you're making. Speaking as a practitioner, I want to know essentially how you apply what you learned. You made some new projects, you added more curriculum materials, you somehow managed to train Dr. Conrad and his staff, and then the students. But like, was that approach driven by like a particular theory or principle, or were there guidelines? Basically, what I'm really trying to ask is like,
Yeah.
if I want to go do all this, what do I need to do? What should I know from what you have already done?
Absolutely. So let's start with table stakes. We more or less, the only thing that we had at the start of the quarter was the example application. I had written the example application over the summer as part of as kind of feeling out this project, and that's the only thing we entered the quarter with. What happened afterwards can only really be described as a mad scramble to put together not only the re-implementations of the legacy code projects, but as you highlighted, even before that, you can do that. You need to train the instructional staff in the basics of how to actually, what is this tech stack? How do you run it on your machine? How do you set up all of the corresponding components? And in order to do that, what we asked the core staff to do was take my to-do web application and essentially do what the students were going to do in what ended up being 7 weeks later, and extend that application to add new features, add edit feature functionality to the to-dos, add the ability to add tags and filters to that list. And these types of essentially having the core staff work through these epics themselves is what allowed them to essentially onboard to the tech stack, both in terms of just running into the common problems of like, oh no, I have two of the same app running on the same port. Oh no, the tests aren't running. Oh no, I need to remember to use Java 11 and not Java 8 because reflection and whatnot. That's really like, I wouldn't say we followed anything so high-minded as some guiding principle, so much as we need to get these MVP projects out as soon as possible. But if we were to just jump in immediately and start implementing them, that might have been a little bit of like a face smack into a wall. So we first decided we're going to implement some features in the example app, and then we're going to cut down and cut out as much functionality in the example app as possible, and use that as a prototype, as essentially a starter repo for all three of the legacy code projects. And then additional onboarding occurs when you take the base application and build out essentially the MVP, the core function of each of those legacy core code projects. So more or less, the way we were able to get core staff to onboard to the tech stack was more or less by necessity. There was no guiding principle. It was, we need this so we can actually assign this to students. And I won't say lucky us, but it's a good thing that actually building these things is directly correlated with how well you actually understand them.
So Scott, can I jump in? And I'd say, I think
Sure.
there may have been a guiding principle.
Fair
That
enough.
guiding principle can be summed up in one word: authenticity. One of the things that's also true is that Scott and I, an experience that we share in common, along with some of the other course staff, which includes Brian Terse, Jackie Mai, and then others to some extent, is that we all had experience in industry with the process that we were trying to replicate. So I think in terms of a guiding principle, at any point, I think one of the purposes of theory and principle is when you're unsure about something, you return to your principle or your theory and you say, what would the theory say about this thing? And that I think is a guiding principle that guided Scott's work and our work as a team in this course. Is when we had to make a decision about something, we'd say, okay, what would be done in industry, and how can we adapt that skillfully to this different context of teaching an academic course? Scott, would you agree or disagree? Have any comments on that?
I would agree, and I would say in large part what what normally happened was when we say, okay, how do we make this more authentic? It was usually in the context of, oh shoot, we don't have this yet. Can we even do this? Can we ask students to do this? And the answer is, well, yeah, because in an industry, sometimes you get slightly unreasonable asks. And essentially we, as a guiding principle, it reminded us that, hey, these projects don't have to be perfect, right? There were a litany of problems with the starter projects that we handed off to students. It was missing key functionality. There were interdependencies between the different projects that students were working on, which is not ideal because it means one group's progress is impeded by another group's progress, right? And our reminder, I guess, our balm on our souls to tell us that we didn't wrong these students is that, no, this is what industry is. Industry is this, but more.
Yeah, I would say this is a feature, not a bug. A couple of comments, follow-up comments from Corey, and then we'll go to Tony, who's next. So Corey writes, I would imagine that the authenticity is a powerful motivator for students. That might mean the materials fall out of date quickly, but that's a separate concern. And he wrote messy authenticity. And yes, I would say that that's a little bit redundant. Authentic software development is always messy. Let's go to Tony Wong.
Hello, Tony.
Hey, thanks for having me. And I greatly enjoyed the talk, Scott. Yeah, my question was, does the course have any assignments that ask the student to work on the actual testing infrastructure?
No. And this is, well, so I should clarify. To the extent that students work with changing or adapting that infrastructure is more or less reduced to, can you set up a repo to talk to CodeCov when you say when you write tests to when you write tests and have them run in GitHub Actions? And in that aspect, no, like we really, it's reduced to configuration, which introduces students to the actors. It says, hello, my name is GitHub Actions. Hello, my name is CodeCov. We are two things that you talk to, but not necessarily how they work, right? If we're like, waving a magic wand and thinking, oh, what would I want students to do? I'd want students to say, be responsible for creating workflow files, right? To understand that GitHub Actions are just, tests running in a box somewhere, and they have the ability to do things, right? Not just run tests, but also send those tests results somewhere else. And CodeCov is certainly not the only coverage report option out there. There are a multitude of other tools like Sonar and Overalls and other tools out there that do provide a similar service, right? And perhaps it'd be worth exploring those, right? If we can wave a magic wand and allow students to explore those, right? That'd be awesome. But we are somewhat constricted by the fact that we only have 10 weeks, and that a lot of times, even just introducing like the entry level knowledge that students have can vary wildly, right? From people who've just finished taking introductory courses and don't even know what HTML is, right? To people who have built React apps that have them deployed on Netlify and have, know how to host a backend and on DigitalOcean, right? Like, you get wildly different experiences. And as a result, like, we usually have to tailor our coursework to just focus on the bare essentials, right? That students need to get up and running with the actual tech stack. And we try to add snippets here and there of drops of knowledge for students that are like, oh, I get this. Oh, hey, look, here's this note about what's actually happening here. But by and large, we have to kind of shift down as opposed to up in terms of course material.
So Tony, I want to thank you for the question. I want to add one thing to Scott's answer, which is that there is an opportunity for students, and this is aimed at answering Tony's question, but also at any students from the audience who would like to kind of explore more the testing environment. So Scott and I had been talking about a lot of different options for his master's project. Last winter, when we taught the predecessor course, one particular student, Cole Bergman, came up to me after the course, he had experienced the fact that, wow, I talked a lot about testing in lecture, but we weren't doing a lot of testing. He said, I'd really like to go deeper into that. That ended up being a 4-student independent study with Cole, Tanae, Jackie, and Brian, who laid a lot of the groundwork so that later when Scott and I were talking about different possibilities for his master's project, we're like, I think this testing thing, I think we could take the work these 4 undergrads did in their independent study and really, really take it all the way. So I think there's an opportunity for individual students who do want to do the kind of work Tony is describing to do that as an independent study. And I would definitely welcome that. Scott is graduating. And so all of the future work that he mentioned there, except for the IDICE paper, is really work that's going to have to be done by other students in the future. So let's go to Professor Chris Hundhausen from Washington State University. Chris, you have the floor.
Thanks, Phil. Scott, really, really interesting work. Very gratifying to see this come to fruition.
Thank you.
And it has been influential in the brownfield courses I teach at Washington State University. My question for you has to do with black box testing and code coverage. So when you gave the example earlier of black box testing as essentially having a suite like Test Cafe simulate user interaction on a web app running in a browser. You talked about how you could write assertions to make sure certain page elements were displayed, and in response to user clicks that were generated through the testing infrastructure. To what degree do you assert the results? So after you hit a submit and get a server response and display data, those data could also be tested end-to-end through black box testing. This is a place where my students don't do a very good job. They'll do all the mouse clicks, but then they don't do any assertions to see whether the data was actually returned properly from the server. I'm wondering if you have any observations from your data set with regard to that.
Yeah, so unfortunately, because of the lack of, I guess there's a significant, worth noting, we don't have end-to-end testing at the moment. So in terms of the actual data set, I can't provide you any information. In terms of my personal experience, in terms of my experience using these different things and the types of tests that people end up writing, you're absolutely correct. It's a very common pitfall to forget to actually assert that when you talk to the database, the table actually filled out, and not that it just filled out, but it filled out with the 5 items that were in the database, right? That you expected to see there because, well, you created them earlier on. And a lot of that, this is actually, speaking from my personal experience here, this is actually a very common problem. It's not just in your head or just limited to academia. It's actually in industry as well. It's common for different companies to basically write out extensions and additional infrastructure to make it easier to write these assertions, because the biggest problem with these types of assertions about data in tables and such is it's so hard to write succinct tests that say your table looks like this. I believe AppFolio, it was one of the engineers' side projects for the better part of a year, essentially to extend an end-to-end testing framework so that you could write a markdown table and have that as a part of the test and use that to directly verify what the table looked like on the browser page, right? So it's, in a sense, unfortunately, no, we don't have any magic bullets hiding under our covers here, but it's at least comforting to know that it's no, you're actually bumping into problems that industry actually experiences as well.
Well, that's reassuring to hear, because I find that is a large barrier for my students. And in fact, you probably find this too, that students have to significantly rewrite their code for black box testing because they have to start naming their HTML elements, giving them IDs, and start doing DOM. It really tests their DOM traversal skills too. You have to do queries on the DOM, and so it requires more. It's probably good for them in that regard. There'd be an interesting follow-up study to see whether their DOM skills improve through end-to-end testing.
Yeah. Also worth noting is that when you do front-end testing, you actually end up experiencing a lot of these similar issues. The library that we use, React Testing Library, does its best to kind of elide as many of these issues as possible. But when you really get down to it, the front end tests are more or less like Cypress and Test Cafe. It spins up a virtual DOM and you interact with that virtual DOM. It's actually at the end of the day no different. It's just that in React Testing Library, there's a lot of helpers to help you identify things other than by test ID, like placeholder or label text or title or text in the div, right? So that's what some of the other libraries are trying to do. But yeah, you're absolutely right. At the end of the day, it would be really interesting to see whether or not the DOM interaction skills leveled up as a result of testing, which very well they might.
So to follow up on Chris's question, one of the things I'm really excited about is that Scott has laid a foundation where kind of our next step would be to go to mutation testing for both the front end and the back end, because I think that's where we will really discover whether the tests, whether the unit and integration tests and even end-to-end tests are actually are actually catching the possible bugs, right? Because you can write all the tests and get 100% coverage without asserting anything meaningful, except that the thing didn't crash. But when you get to mutation testing, it has to actually work. The test has to actually catch real bugs. Chris, did you have anything more before we go on to Jackie?
No, just congratulations again. Great work.
Yeah, and thanks for being here. So we have one more hand up. I think we can take a couple more questions after Jackie's if people raise their hands. If people don't know how to do the blue hand thing, I will do a check after Jackie's question to see if anyone wants just to unmute their mic and say a few words. But otherwise, let me go to Jackie Mai, who was one of the 4 undergrad students who helped develop the baseline that we then built on. So Jackie, you have the floor.
Hello.
Hey, Jackie.
Yeah, what's up? First of all, yeah, your project is dope. It's super cool to see. This course has been like redone like I think 3 times, and like every single time it's been offered. So it's cool to see it's kind of coming together now. So my question is kind of about that. Let me see. You sort of talked a lot about like the end result, like, oh, students wrote tests. This is what their tests look like. But you also talked like, you introduced 3 different frameworks for unit testing and like the different levels of development. And you did mention, I think one quote that you gave was that like CS course curriculums are really saturated.
Yes.
So I guess I'm kind of interested in like the instructional techniques you chose to like introduce these frameworks to students. Like what did you choose to take out of the original course to sort of get them familiar with these things, and like how effective did you think that was?
So this is actually one of like the biggest, I guess, shortcomings of essentially having this be a transition quarter, was that because we were scrambling to get everything together during the quarter, there were definitely some shortfalls in terms of the onboarding experience of the students, certainly the course staff as well, but especially the students. And essentially what we found was the following. Students did all the labs right up until week 7. We handed out projects and assignments on week 7.5, borderline week 8. And students started implementing, and then ran face first into the wall, right? Where they basically were like, wait, I don't know actually how to write the test for this. And this is a huge shortcoming in terms of the actual, the instructional materials that we put out. To call them cursory, or I guess a too early of a preview would be nice, essentially. We made the effort to, but we were basically so focused on not drowning and trying to get the legacy code projects out that it more or less, we paid for it in the back end by, in my instance, I think I had 4 10-hour days back to back to back, where I was basically helping students in the final week leading up to submission deadline get their code tested. It would be more or less, I'd get on for 10 hours straight, and then I'd get off and eat dinner, and then I'd get up tomorrow and I'd do the same thing again. And that is definitely one of the things we want to fix going into next quarter. But thankfully now, because the course projects actually exist, we can instead move all of that mad frenzy energy that we had and move it towards course assignments instead and focus it there and actually have like a meaningful lab where you say, we'll hand you an incomplete to-do application and we're going to ask you to implement a feature and test it before you get to the actual legacy code app, so that you had an experience where you had to test an app using this tech stack and you actually ran into some of the issues like, how do I mock a call to the API? How do I, what is this jest.fn thing? What is this jest function? What is Mockito, right? What is this framework I use to mock and stub things? What is mocking and stubbing? Why do I need asserts? Stuff like that. Yeah, and hopefully move that balance back from like 7.3 to make it like 3.7 instead.
Yes. Yeah, one of the things, so Jackie has some skin in the game here because she's going to be one of the TAs for the course next quarter. Jackie, I hope you are not frightened by what Scott just said. The 10-hour days were real, but that was part of the transition and also part of, kind of the effort of Scott doing his master's project. Now that we have these 3 legacy code apps built out, I think we'll be able to onboard the students to that much earlier in the quarter. I've been going through identifying a lot of good first issues, low-hanging fruit, where we can introduce students to the process of doing a feature branch, writing code, getting it into, making a pull request and merging it much, much sooner. And we have the existence of all of these repos where we can build lessons and labs that draw from the examples we have in the code. So I think the next quarter is going to go much more smoothly than this transition quarter. So yeah, next quarter is not a transition quarter. Next quarter, finally, we get to just, I don't want to say coast, but we're not trying to build something brand new from scratch next quarter. So Jackie, anything more from you?
Yeah, I guess maybe just a small follow-up question is, it seems like there's a lot of things you want to introduce. Are you concerned about making the curriculum like bloated? Because I mean, at a certain point, you're just like throwing names at them. Like, yeah. Are there things you found that maybe you don't need to spend as much time on, or you want to take out entirely?
Yeah, so actually at the moment, there's a bit of, we're actually suffering, instead of a bit of bloat, we actually have a bit of vacuum, and the vacuum occurs in the first 7 weeks, right? We essentially did not really have enough solid material during the first 7 weeks in order to supplement. Now, part of the problem is that shouldn't have been 7 weeks, right? But you're absolutely right. Like, there definitely needs to be some controls on like how much of this we're actually feeding into the course. And another thing worth pointing out here is that the goal isn't necessarily to give every student a uniform experience, right? This is actually a very key thing to understand about this course, is that unlike most courses, the goal is not everybody gets the same cookie cutter experiences because they got the same labs and the same assignments. The goal is to give each student an individual, yes, but an authentic experience as a result of that they can then go, say, for example, share with a future employer during an interview and such, right? So in that sense, I'm not worried about bloat necessarily, because it's okay if some students don't interact with some of the portions as much, right? If a student tends to live more on the front end and another student tends to live more on the back end, that's not a bug, it's a feature, right? And as a result, we can afford to introduce some more topics than, say, another course might be able to.
Also, the course moved from the lower division to the upper division too. So I think it's also true that compared to the CS56 instances of the past, our expectations have been gradually ramping up. And it is definitely an upper division course kind of experience now. So it's, rather than comparing it with, say, CS32, we should be comparing it with CS170 or CS160 in terms of
effort.
Just both the quantity and the quality of the content in the course.
Yeah, that makes a lot of sense. Don't have any other questions, but congratulations again. It's dope.
Thank you.
All right, so let me leave just a moment for anyone else that may not know how to use the blue hand feature in Zoom. If you'd like to unmute yourself and say a few words, now is the time for that.
Hi, Scott, it's your sister.
Hey, Michelle.
So I don't really know much of the, lack of a better word, jargon that was thrown around in my little nursing brain. Can really comprehend some of it, but I did my best to understand it. You're cool. Like, you did that. That's fantastic. That's really cool. Like, I couldn't have for certain. You redesigned a whole course essentially, for lack of a better way of putting it. So you're cool. Love you and miss you. This is fantastic.
Thank you, Michelle. I love you and miss you too.
You have an awesome brother, Michelle.
Hey, he's all right. No, he's the best.
So one of the very first TAs for this course was Kyle Jorgensen, and he shared some nice material in the chat. Want to draw everyone's attention to that. Kyle, would you, no pressure, if you prefer to pass, that's fine. But would you like to unmute and share a few thoughts?
Hi there. Yeah, I'm Kyle. I missed some of the early part of the presentation, but I looked through the slides. I don't have much to add other than, like, looks amazing. The work is really cool. Like, great job, Scott. Go Gauchos. Go UCSB Computer Science.
Thank you.
Thanks, Kyle. Anyone else?
Yes, Scott's father. Scott was also into computers many years ago and retired at it. Yeah, I find it interesting that he took up testing because since I graduated in 1980 and testing wasn't really taken that seriously, IBM tried to instill it with quality circles and stuff, and to find it many years later in many iterations of supposedly better code, the same problem still exists. So I'm glad that some attention has been paid to something that's, a new code and better wheelhouse, still flawed because people coded.
Well, thank you, and it's an honor and a pleasure to have you here and to have an opportunity to work with Scott.
Congratulations.
Thank you.
Thanks, Dad.
All right, well, that might be a good note to go out on. So once again, let's all congratulate and thank Scott Chow. Thank you, Scott. And we will go ahead and end the recording here.